Hello everybody, welcome to Marketing Analytics course. This is Dr. Shagata Chatterjee from VG Somayati Kharagpur who is taking this course for you. We are in week 10 session 4 and we will be discussing about text mining. So, in the last class we have discussed about text mining in the context of reading a data. Martin Luther King's data we have read, and then we have done some amount of pre-processing of the data. And in this particular class, I will discuss about a new thing which is called spam detection, and we will be using a naive Bayes algorithm to do that. So, before I start, we should discuss a little bit about what is Bayes theorem, and we have done this in probably in our statistics class very early days, but I will just repeat once more. So, if you remember that there was a thing called probability. What is probability? Probability of anything, any event is basically number of times that event is occurring divided by the total number of observations. That is something called probability of a particular event. So, then let us say in a particular class, there is a particular class, there are 8 male are there and let us say 5 female are there. And out of this 8 male, 4 are wearing spectacle, 4 are not wearing spectacle, and out of this 5 female, 3 are wearing spectacle and 2 are not wearing spectacle. Now, my question is that what is the probability that if I blindly choose some person in this from this particular class, that person will be a male. What is the probability of male? So, what is that answer? Number of male by total number of observations. Fair enough. So, what is the number of males here? Number of male is 8, total number of observation is 13. So, 8 by 13. If I say what is the probability if I blindly choose somebody, he will be wearing a spectacle. So, if you see that in this thing there are 7 people who are wearing spectacle and there are 13 number of people. So, this is how we generally try to find out probability. Now, my question is that listen to this question carefully. So, if I choose from main, or given that my choice is main is male, whatever be the language, what is the probability that the randomly chosen person is wearing a spectacle? That is the question. That if I choose from main, what is the probability that a randomly chosen person is wearing a spectacle? So, how will I answer that? What is given here? So, if this is something that I am asking you, so then probability of something, I will write it later. So, how many? So, if I choose from main, that means the total number of people, total number of possible cases, unique possible cases is basically the number of male, and he has to wear spectacle means number of male wearing spectacle. That is something that we are trying to find out, number of male and number of male wearing spectacle. So, if I try to write this in mathematical term, whatever the probability that we are trying to find out is basically n of m, and n of m and s. What is and? And means both are things are happening. Male is happening, that the person is male, and spectacle is happening, that means he is wearing spectacle, both are happening. Now, if I just divide it both numerator and denominator with 13, which is the total number of persons, then do I get this? From here, if I divide the both numerator and denominator with the same value, then it remains same. So, then this numerator becomes P of m given S and the denominator becomes P of m, and this particular part we call it as S given m. Why S given m? Because male is given, this is given, this is will happen, this is assured, and this is the stochastic part. This is something which is not assured. Okay. So, that is why S given m. So, using this similar thing, there is something called Bayes theorem, which is P A and B by P of P. This is called Bayes theorem, and this is something that we will use here. Before I go ahead with Bayes theorem, we will do a little bit of maths on this particular formula. Can I just write? So, from here can I write this? See, the numerator remains same and this denominator, which has been P b, is pushed here. So, this denominator, which is P b, this one I am pushing it to this part. So, this one I am pushing it to this part. This guy I am pushing it to here. So, that is what I am doing, and while doing that I am getting this formula. Fair enough. Now, if this formula is true, what is the difference between difference of A and B and B and A? Is there any difference? A and B and B and A, is there any difference? So, if I say that you and I are going to the school versus I and you are going to the school, the persons who are going to the school, are they different? Probably not. So, if these two are not different, can I write this one just replacing A and B? If this is true, then this is also true, no? Just replaced A and B in their spaces. And if I can replace A and B in their spaces, I put A in this side and B in that side, just replacing this place. Then, and if these two guys are same, then these two guys are also same. If the right hand side of these two equations are same, then the left hand side of these two equations are also same. In fact, the other way, the left hand side of these two equations are same, then the right hand sides are also same. That means P of A given B into P of B is equal to P of B given A into P of A, right. So, that was the formula. So, or P of A given B is P of B given A into P A by P B. So, this is another formulation of Bayes theorem. So, these two formulation, just remember these two formulation, we will be requiring to do something called Naive-Bayes algorithm. We are doing spam detection. So, what is spam detection? Fair enough. So, just tell me that what exactly do you understand as spam? So, the spam term, if I am not wrong, came from a burger, where the burger was not good or something like that. So, not good burger was named as spam and good burger was named as ham or something like that. So, you just read in Google, there is a history of spam and ham. Why there are these two terms? Basically, in your email, whatever mail comes, or in your SMS box, whatever SMS comes is, whatever SMS is useful to you, that is something which is ham, and whatever is not useful to you is something called spam. So, this is how we name spam and ham. Ham is something which is useful and spam is something which is not so useful. So, spam is not useful, spam is not useful, and ham is something which is useful. So, we have to find out. Now, if you remember, at one point of time Google was not doing good job, or Yahoo was used to not doing good job in spam detection, but nowadays they do very good job in spam detection. So, there are some ways that they follow. One of the basic ways to do that is this knife based classification. So, any classification is basically a supervised learning. So, if you have, I hope that people who are in this class have done introduction to business analytics, and I hope that there what is supervised and what is unsupervised learning has been discussed. If not, search Google. So, this classification is a supervised learning, where you have to be pre-give to this particular classification algorithm that which of your observations are spam and which of your observations are ham. There will be past data which are pre-labeled for the learning purpose. So, let us say there is certain 100 emails that you got, and out of them 20 were spam, 80 were ham. You manually check that. And you are also checked about the word. There was a word called Viagra that is very common in US based spam mails, and you will see that out of these 100 SMSs or emails that you checked, 5 had the word and 95 did not have the word. And if I just convert this table to the probability table, it looks like this. So, 4 by 20, 1 by 80, 5 by 100, 95 by 100. Now, then what is the probability that a SMS will be a spam given that there is a word Viagra? If the word is present, what is the probability that it will be a spam? That is V given S into probability of S by probability of V, is it not? It is V given S by probability of. So, what is I would say V given S. So, I will just delete this probably. So, what exactly is this V given S? So, given that it is spam, what is the probability? It is Viagra. If you check, the thing is 4 by 20. What is the probability of spam? It is 20 by 100. What is the probability that Viagra will occur? 5 by 100. So, the net probability is 4 by 20 into 20 by 100 divided by 5 by 100 comes up to be 4 by 5, which is 0.8. That means that if Viagra word is occurring, that means Viagra word is there in my message, the probability of the message being spam is 0.8. If this value is higher than a cutoff that you set on your own, if this particular value is higher than a cutoff that you set on your own, then that particular message will be a spam message. So, that is how we try to deal with spams. Now, this is very simplistic. This is naive based because it is naive, it is very simplistic to find out that probability, and it is based out of Bayes theorem. That is why this is naive based. What are the strengths? It is simple, it is fast and very effective, does well with noisy and missing data. So, even if some of the data is missing or noisy, it can handle that. It requires relatively few samples for training. So, the data set that is required, the training data, the past data that is required might be small, no issues, and also works well with very large number of examples. So, even with if it is large or small, it can handle it, and easy to obtain the estimated probability for a prediction. So, that is something which is strengths. What are the weakness? The weakness are it relies on an often faulty assumption of equally important and independent features. So, we will discuss about that. This particular thing we will discuss at the moment I go to the next slide. They are not ideal for data sets with large number of numeric features. So, generally it can handle only categorical variables like Viagra word yes or no, it is a categorical thing. So, that kind of situations it can handle better rather than numeric variables. And estimated probability. So, that is why in text mining it is used more than other classification problems, and estimated probabilities are less reliable than predicted class. So, it is better to predict whether it is a spam or ham using this, not what is the probability, because remember this particular thing is not good with numeric data. So, if you want to do let us say credit scoring tries to find out the probability of somebody will default or not. So, they are good in finding out the probability, they are not good in finding out exactly classification and saying that okay, this guy will be defaulter and this guy will not be defaulter, but that gives probability. So, similarly, here if you try to get the probability of defaulting or not defaulting, that kind of a problem, it will not do good job. But if you try to find out whether it will be a spam or a ham, a classification problem instead of a probability as an outcome, then it will do a good job. So, that is something which are the weaknesses of this particular thing. Now, imagine we do not create spam detection techniques, or we do not create, I would say, classifications of spams or hams based on only one word. We generally do with multiple words. So, let us say whatever I did for that 100 things, I got 20 spams, 20 hams, and instead of one word I did it for 4 words. So, Viagra, then money, then groceries, then unsubscribe. These are the 4 words very commonly found when people send mass mails or mass SMSs mainly in US probably. These words are very common, and correspondingly the probability distribution is given there, yes, no, blah blah blah. Now, the question is that a message has the words Viagra and unsubscribe, and but does not have the word money and groceries. What is the probability of being spam? So, let us write it in mathematical way. So, I am writing what is the probability of spam given that V and U, these 2 words are there, and M dash and G dash, that means M and G, these 2 words are not there. So, if I just follow the normal base formula, this is V comma U comma M dash comma G dash given S into P of S by P of V comma U comma M dash comma G dash. Comma means intersection. So, P A comma B means A and B are both occurring, which is basically A intersection B. Okay. So, this is something. Now, I do not have V comma U comma M dash comma G dash, that value I do not have. So, here the assumption comes in, and that is a failure, relies on often faulty assumption that equally important and independent features. So, we are bringing in that these features, which is the words, are independent to each other. Might not be the case, probably sometimes money, grocery or unsubscribe might be related. In a same, the probability of having a grocery related email and having unsubscribe word written there might be very high. So, they might be related, but here for our simplicity purpose, we are assuming that these words are unrelated. Now, if P A and B, if A and B are independent, then this is equal to P A into P B, if you remember that formula. So, using that, what I am writing here is P of V given S, P of u given S, P of m dash given S, P of g dash given S into P of S divided by P of v, P of u, P of m dash and P of g dash. What is the assumption? You should write this thing. Assumption is the words are independently occurring. Now, tell me the value of v given S. What is the value of v given S? Given that it is spam, what is the value of what is the probability that it will be Viagra? It will be 1 by 80, right? Check carefully, it will be 1 by 80. No, no, it will not be 1 by 80. It will be 4 by 20. Right or wrong? Yeah. So, then what is u given S? U given S is unsubscribed. You see this value, this value. So, basically 12 by 20. Then what is m dash? M is not occurring. So, this 10 by 20. Then the last one is g dash, g is not occurring. So, 20 by 20 into what is P of S? That is 20 by 100 divided by P of V, which is 5 by 100 into P of U, which is 35 by 100 into 76 by 100 into 91 by 100. Whatever value comes, that value, if it is higher than whatever cutoff you have decided, then it is high, otherwise low, otherwise it will not be a spam. So, this is how we calculate. What is one of the limitation? One limitation is that I am assuming that the words are independently occurring. Now, another small problem that I will discuss. Let us say somebody asked me this question, that a message has all words, Viagra, unsubscribe, money, groceries, all these 4 words are there. What is the probability of being spam? Okay. So, if all words are there, what will change in this whole story? In this whole story, this will be m, this dash signs will go away. So, here also this dash signs will go away. Fair enough. If these dash signs go away, then how much will be the value at the bottom? This value and this value. This value and this value becomes, let us say 8 by 100 and 24 by 100. Are you with me? What happens in the numerator? The numerator, this remains 10 by 20, no issues. But this guy all of a sudden becomes 0 by 20. The whole value thing becomes 0. So, if the whole value becomes 0, even if these are very high, let us say these are 1, instead of 10 by 20, these are 1, still it will become 0. So, all other words are saying that, heavily saying that, okay, this is a spam, this is a spam, this is a spam. Still, if one observation is by chance coming 0 and that is one of the thing that is occurring, the whole thing becomes 0. That is a limitation, it has a 0 limitation. So, to solve that, what we do is we use a Laplace estimator. What is Laplace estimator? We say that this is not 0, this particular value, we say this is not 0. This is a small value, let us say 1. If this is 1 and this is 19, let us say if the instead of 100 data points, if there were 5,000 data point or 50,000 or 1 lakh data point, then in that 1 lakh data point, if I change, if it is 0 by 20 and this is 1 lakh by 20, instead of that, sorry, 1 lakh by 1 lakh and that is 0 by 1 lakh, instead of that if I just write 1 by 1 lakh and here 99999 by 1 lakh, will that change the whole picture? A lot, it will not change, but it will save me from this 0 thing. So, that is what we try to do. We call it Laplace estimator and we put a very small value for this thing. Now, somebody asked me, or we discussed in the limitation, that we cannot handle this particular thing, cannot handle a categorical continuous data. So, for continuous data what we generally do is something called binning. What is binning? So, let us say at our childhood days, I am not sure whether that was the case in your case also, whether you have faced this kind of situation. For when I started using email for the first time, it was long back, and at that time all the servers of email were in US countries or Russian countries and etc. So, when it was working hour at their time, it was a sleeping hour in our time. So, what I used to see that in the morning when I check the email, there will be lots of I would say spam emails, because all these spam emails are pushed in the night when it is the working hour for USA and Russia. Now, spam email comes at every point of time, it does not matter whether it is day or night or what kind of a time, but at that point of time there was a time variable. The time of the day was also important to measure that whether a particular mail is spam or ham. So, what we do given that is the time is 24 hours. So, I can break that 24 hours in 24 bins or at least in 4 bins. So, see this 6 to 18 is when the frequency is high. So, I say this is night, or let us say evening, this is early morning, this is daytime 1, daytime 2. So, whenever daytime 1, daytime 2 comes, there will be a higher chance of being a spam, and here it comes. So, we basically change numeric factors to bins, but the moment we do binning, we lose a little bit of variation. So, here there is some variation, here there is some variation which we are losing, but we have to take care, because otherwise it becomes very difficult to handle numerical data in this particular algorithm. So, that is all on naive Bayes. In the next video, we will actually discuss about how to use naive Bayes algorithm to spam detection using R as the code. Thank you very much. I will see you in the next video.